Hello there, petrol heads. Today, we're diving into the fascinating world of nitrogen and air engines. These revolutionary technologies could change everything we know about driving, offering a future where cars no longer rely on fossil fuels. Imagine driving through a bustling city without the noise and pollution of traditional engines. Cleaner air, quieter streets, and a reduced carbon footprint. These engines could be the key to a sustainable future. Sounds like science fiction. It's very real. Engineers are working tirelessly to perfect these technologies. Imagine a car that runs on air or nitrogen, drastically reducing emissions. In the following sections, we'll delve deeper into each type of engine. So buckle up and get ready for a fascinating ride into a cleaner, greener future. Let's start with nitrogen engines. Now, nitrogen is all around us. It makes up a whopping 78% of the air we breathe. But unlike the petrol in your car, nitrogen doesn't burn. So how can you power an engine with it? Well, a nitrogen engine works by using the expansion of nitrogen gas to generate power. Imagine a canister filled with nitrogen under high pressure. When this pressurized nitrogen is released into a cylinder, it expands rapidly, pushing a piston. This piston movement, in turn, drives the vehicle's wheels. Think of it like those party poppers you pull at New Year's. The sudden release of compressed air creates a popping sound and propels confetti into the air. A nitrogen engine works on a similar principle, just on a much larger and more controlled scale. One of the biggest advantages of nitrogen engines is their environmental friendliness. They produce zero harmful emissions. That's right, absolutely nothing but harmless nitrogen gas comes out of the exhaust pipe. This makes them a very attractive option in our fight against air pollution and climate change. Another plus point is the quick refueling time. Imagine filling up your car with nitrogen in the same time it takes to fill your petrol tank today. That's the kind of convenience nitrogen engines offer. No more waiting around at charging stations. This combination of zero emissions and quick refueling makes nitrogen engines a compelling alternative to traditional petrol and even electric vehicles. But as with any new technology, there are challenges to overcome. One of the main challenges with nitrogen engines is their energy efficiency. While they produce zero emissions, the process of compressing and storing nitrogen requires a significant amount of energy. This means that the overall efficiency of nitrogen-powered vehicles is currently lower compared to some other alternatives. Another challenge is the storage of nitrogen. To store enough nitrogen for a practical driving range, it needs to be kept under very high pressure. This requires specialized, heavy tanks, which adds to the vehicle's weight and complexity. Researchers are actively working on overcoming these challenges. New materials and technologies are being developed to improve the storage and efficiency of nitrogen engines. However, these improvements will take time and investment to become commercially viable. Now let's talk about air engines. As the name suggests, these engines use compressed air as their power source. But unlike nitrogen engines, which rely solely on the expansion of compressed gas, air engines often incorporate additional steps to improve efficiency. One common approach is to use the expanding air to heat another fluid, like water or oil. This heated fluid then turns into steam or vapor, which drives the engine's pistons with greater force. Essentially, it's like using compressed air to power a miniature steam engine. This method of using a secondary fluid can significantly improve the efficiency of air engines compared to simply relying on air expansion alone. The perks of air zero emissions and wallet-friendly operation. Like nitrogen engines, air engines offer significant environmental benefits. They also produce zero tailpipe emissions. This makes them a very attractive option for urban environments struggling with air pollution. Another major advantage is their low operating cost. Since they run on compressed air, they eliminate the need for expensive petrol or diesel. Imagine never having to visit a petrol station again. This can result in significant savings for drivers over time. The combination of zero emissions and low operating costs makes air engines a compelling alternative to traditional combustion engines, especially for city driving and short-distance commutes. The air engine's Achilles heel range and efficiency concerns. Despite their advantages, air engines also face significant challenges. One of the biggest hurdles is their limited range. Storing enough compressed air for long distances requires large, heavy tanks, which can compromise the vehicle's performance and practicality. While the use of secondary fluids can improve efficiency, air engines still lag behind petrol and electric vehicles in this department. The process of compressing air and converting it into mechanical energy involves inherent losses, reducing the overall efficiency of the system. These limitations mean that air engines are currently best suited for niche applications, such as short-distance urban transport or specialized industrial vehicles, where their zero-emission operation and low operating costs outweigh their range and efficiency limitations. Nitrogen versus air, a head-to-head comparison. Both promise zero-emission transportation, but how do they compare? Nitrogen engines refuel quickly, similar to petrol, offering convenience. However, they require heavy, high-pressure tanks. Air engines can be more energy efficient, but are limited by range and heavy compressed air tanks. Innovations like Tata's AirPod and Dearman's liquid air engine show the potential of these technologies. The race for sustainable transportation continues. A greener tomorrow. The future of nitrogen and air engines. These innovative technologies promise to reduce our carbon footprint and offer a viable alternative to traditional fossil fuels. Imagine nitrogen-powered taxis and air-powered delivery trucks, reducing emissions and noise pollution. The road to a greener future is paved with innovation. These technologies are being developed and tested in real-world scenarios. With continued innovation and commitment, we can make this vision a reality. GAP3S. The journey of nitrogen and air engines began decades ago with visionaries who sought cleaner, more sustainable energy solutions. The concept of using compressed air as a propulsion method dates back to the 19th century, when it was first used in mining operations and early locomotives. Despite its potential, it wasn't until the late 20th century that significant advancements were made. In the 1970s, the oil crisis spurred renewed interest in alternative fuels, leading to the development of the first modern air engine prototypes. These early models demonstrated the feasibility of using compressed air as an energy source, but faced challenges in efficiency and storage. The 1990s saw the introduction of nitrogen engines, leveraging the principles of air engines but utilizing liquid nitrogen for improved performance. Pioneering companies and researchers began to refine these technologies, focusing on increasing range and reducing energy loss. The 21st century has brought remarkable milestones. In 2007, the first commercially viable air car was unveiled, capturing global attention. Meanwhile, advancements in materials science and thermodynamics have significantly improved the efficiency and practicality of both nitrogen and air engines. Today, collaborative efforts between academia, industry, and government are driving further innovation. Cutting-edge research is exploring hybrid systems, combining nitrogen and air engines with renewable energy sources for even greater sustainability. From early experiments to modern breakthroughs, the history of nitrogen and air engines is a testament to human ingenuity and our relentless pursuit of a greener future. As we continue to push the boundaries of what's possible, these technologies hold the promise of transforming transportation and energy sectors worldwide. GAP3S. And so, the journey continues, fueled by innovation and a collective commitment to a sustainable tomorrow. GAP3S. As we look to the future, it's crucial to compare the environmental impact of nitrogen and air engines to that of traditional combustion engines. Combustion engines, which rely on burning fossil fuels, are notorious for their harmful emissions. They release significant amounts of carbon dioxide, nitrogen oxides, and particulate matter into the atmosphere, contributing to air pollution and climate change. In contrast, nitrogen and air engines are celebrated for their zero-emission operation. By using compressed air or liquid nitrogen as a fuel source, these engines produce no harmful pollutants during operation. This means cleaner air and a significant reduction in greenhouse gas emissions. Moreover, the production and disposal of fossil fuels have severe environmental consequences, including habitat destruction, oil spills, and water contamination. On the other hand, the primary byproduct of air engines is simply, well, air. Nitrogen engines produce nitrogen gas, which makes up a substantial portion of the Earth's atmosphere and poses no environmental threat. However, it's important to acknowledge the energy required to compress air or liquefy nitrogen. If this energy comes from non-renewable sources, the overall environmental benefits could be diminished. That's why integrating renewable energy sources into the production process is essential for maximizing the green potential of these technologies. In summary, while no technology is without its challenges, nitrogen and air engines represent a significant step towards a more sustainable future. By minimizing harmful emissions and reducing our reliance on fossil fuels, they offer a cleaner, greener alternative to traditional combustion engines. As we continue to innovate and improve these systems, the potential for a healthier planet becomes increasingly within our grasp. Gap 3S. Let's embrace these advancements and work together to drive towards a brighter, more sustainable tomorrow. Gap 3S. As we delve deeper into the world of nitrogen and air engines, it's crucial to hear from those at the forefront of this innovative technology. Today we'll be joined by Dr. Emily Carter, a leading expert in sustainable energy systems, to discuss the future potential and challenges of nitrogen and air engines. Gap 2S. Dr. Emily Carter. Thank you for having me. The potential of nitrogen and air engines is truly exciting. These technologies promise a future where transportation is not only efficient, but also environmentally friendly. One of the most significant advantages is their zero-emission operation, which could drastically reduce air pollution and our carbon footprint. Gap 2S. Voiceover. Dr. Carter, can you elaborate on the main challenges these technologies face? Gap 2S. Dr. Emily Carter. Certainly. While the benefits are clear, there are hurdles to overcome. One major challenge is the energy required to compress air or liquefy nitrogen. If this energy isn't sourced from renewable resources, we risk negating some of the environmental benefits. Additionally, the current storage and efficiency levels of these engines need significant improvement to make them a viable alternative to traditional combustion engines. Gap 2S. Voiceover. That's insightful. What steps are being taken to address these challenges? Gap 2S. Dr. Emily Carter. There's a lot of ongoing research focused on improving the efficiency and storage capabilities of these engines. Innovations in materials science and engineering are paving the way for more robust and efficient systems. Moreover, there's a strong push towards integrating renewable energy sources into the production process, which would significantly enhance the overall sustainability of nitrogen and air engines. Gap 2S. Voiceover. Thank you, Dr. Carter, for sharing your expertise. It's clear that while there are challenges ahead, the future of nitrogen and air engines holds immense promise. As research and innovation continue to evolve, we may soon witness a revolution in how we power our vehicles, leading to a cleaner and more sustainable world. Gap 3S. Voiceover. Stay tuned as we continue to explore the fascinating world of nitrogen and air engines and the groundbreaking technologies shaping our future. Gap 2S. As we continue to explore the potential of nitrogen and air engines, let's take a closer look at real-world success stories that are setting the stage for a sustainable future. One such example is the innovative work being done by the company Green Fleet Solutions. Gap 2S. Green Fleet Solutions has successfully developed and implemented nitrogen-powered delivery trucks in several urban areas. These trucks have shown remarkable efficiency and have significantly reduced emissions compared to their diesel counterparts. Gap 2S. In an interview, the CEO of Green Fleet Solutions, John Smith, shared insights into their journey. Gap 2S. As we've journeyed through the world of nitrogen and air engines, it's clear that this technology holds immense promise for a greener future. From the pioneering efforts of companies like Green Fleet Solutions to the potential for zero emissions and cost-effective operation, the possibilities are vast and encouraging. But like any emerging technology, challenges remain. Issues of efficiency, storage and range need to be addressed before nitrogen and air engines can become mainstream. However, the progress we've seen so far is a testament to human ingenuity and the relentless pursuit of innovation. The automotive industry stands on the cusp of a revolution. Whether it's through nitrogen, air, or other sustainable technologies, one thing is certain. The future of transportation is set to be cleaner, smarter, and more environmentally friendly. Thank you for joining us on this exploration. Stay tuned for more insights into the technologies shaping our world and driving us toward a sustainable tomorrow.